Welcome to the Explainer. Today, we're doing a deep dive into a really powerful statistical tool, the XmR chart. So if you've ever found yourself staring at a single data point, one number per month, or per week, or per day, and wondering, is this good? Is this bad? Is anything really changing? Well, then this is for you.
All right, here's how we're going to break it down. We'll start with the core problem we're trying to solve. Then, we'll introduce our hero, the XmR chart. We'll pull it apart to see how it works, build one from the ground up, see how it plays out in the real world, and finally, figure out exactly when you should be reaching for this tool over others.
So first things first, let's really frame the problem here, because it's a super common one in business that most of the standard charts just can't touch.
I want you to think about your own world for a second. We're talking about monthly sales numbers, maybe daily blood pressure readings for a single patient, or even the number of customer complaints you get each week. You've just got this one lonely data point for each period. So when that number suddenly jumps up or drops down, how can you possibly know if that's a real signal, a sign that something fundamental has shifted, or if it's just, random noise? That's the lone data point problem.
And that, right there, is precisely the job that the XmR chart was built for. You might also hear it called an IMR chart, Individuals Moving Range. It's designed to bring real statistical muscle to situations where your sample size is exactly 1.
So what is it, really? Well, at its core, the XmR chart is a dynamic duo. It's actually two charts working in tandem to give you this complete, moving picture of your process. It helps you see the difference between a real change and just the everyday static, all from a simple string of individual numbers.
And you can see it right here. This is the key. It's answering two totally different but equally important questions. The top chart, that's the individuals or X chart. It's tracking the actual values you measured. The bottom chart, the moving range or MR chart, that's all about the jumpiness between those values. One tracks the what, the other tracks the consistency.
Okay, let's dig into that a little deeper. Understanding exactly what each of these two charts is doing is the secret to really unlocking what the XmR chart can tell you.
This really lays it all out. Think of it like this. The X chart on the left is asking, is our average level of performance changing? But the MR chart on the right, it's asking a totally different question. Is the predictability of our performance changing? Because you could have a perfectly stable average, but with wild, unpredictable swings happening underneath. The MR chart is what shines a light on that hidden chaos.
All right, enough theory. Let's get our hands dirty. It's time to actually build one of these charts from scratch, and we'll use a real-world example to do it.
So here's our data. Picture a quality engineer on a factory floor. They're grabbing individual steel fasteners one by one as they come off the line and measuring the temperature. We've got 20 of these measurements in a row. Our job is to figure out if this process is stable, if it's in control.
Building this thing is actually a pretty straightforward 4-step process. First, obviously, you just list your measurements. Those are your X values. Step 2 is where the magic starts. We calculate the moving range, which is just the absolute difference from one point to the next. So the first moving range is just the difference between point 2 and point 1. Easy. Once we've done that for the whole series, we just calculate the average for both columns. And those averages, they become the center lines for our two charts and the foundation for everything else. So, first up, the easy one. We take all 20 of our temperature readings, add them up, and divide by 20. Boom! That gives us our process mean, our X bar, which is 31.7. That's going to be the center line on our top chart. Next, we do the same thing for our moving ranges. We calculated 19 of those little point-to-point differences. We add them all up, divide by 19, and we get our average moving range, or R bar, of 4.9. This number represents the average short-term variation in our process, and it becomes the center line for our bottom chart.
Okay, now hold on. Let's pause here for a fantastic, really sharp question that trips a lot of people up. Even seasoned pros ask this. If we're plotting individual data points where our sample size, n, is obviously 1, why on earth do the formulas for the control limits use constants that are based on a sample size of 2?
And the answer is actually, well, it's pretty elegant. While the top chart, the X chart, is plotting individual points where n is 1, the bottom chart, the MR chart that's all about variation, is built on the relationship between pairs of points. Every single moving range value comes from two measurements. So when it comes to calculating the limits for our process variation, the effective sample size is always 2. It's a subtle point, but it's absolutely critical.
Okay, so we've built the chart, we get the math, but so what? Let's talk about how you actually use this thing as a strategic tool in a real project.
This is where the data turns into actual decisions.
The XmR chart is an absolute workhorse in the Six Sigma DMAIC framework. Let me paint you a picture. Imagine you're trying to reduce customer complaints. In the measure phase, you chart your monthly complaints on an XmR to get a baseline. Then, after you roll out some changes in the improve phase, you use that same chart to see what happened. Did the average number of complaints go down? And just as important, did the variation shrink? Is it more predictable? Finally, you just keep the chart running in the control phase to make sure you hold on to those gains.
And please, do not think for a second that this stuff is just for factories. The principles of statistical process control apply to literally any process. This is for HR, tracking onboarding times. This is for finance, looking at inventory levels. This is for marketing, tracking monthly leads. If you have a single data point you collect over time, an XmR chart can tell you things you never knew.
Now, as powerful as the XmR chart is, a true pro knows that you have to use the right tool for the right job. So let's put it into context with its cousins so you know exactly when to grab this one from your toolkit. And honestly, here's the key takeaway. It all boils down to one simple question. What's your subgroup size? If you're measuring one thing at a time, n equals 1, the XmR chart is your guy. If you're collecting data in small batches, say 2 to 10 at a time, you'll use an XBAR and R chart. And for bigger groups, you'll use an XBAR and S chart. Your data collection strategy tells you which chart to use. It's that simple.
Before we wrap up, a couple of golden rules you have to remember. First, and I can't stress this enough, never ever put your customer specification limits on a control chart. They don't belong there. Your control limits are the voice of your process. They tell you what your process is actually doing. Specification limits are the voice of your customer. They tell you what you want it to do. They are two totally different things. And second, remember the chart is just a smoke alarm. It tells you there's a fire. It doesn't tell you what caused it. That's still your job.
So I'll leave you with this question. Now that you have this new lens, a way to see not just the average of a process, but its variation, its predictability, what problems that are hiding in plain sight in your own work could an XmR chart finally drag out into the light? What stable process is actually far more chaotic than you think?